All right, IM3 fans, our topic for today, this is Module 5, Section 1, Functions and Relations. Our objectives after this lesson, students should be able to, number one, understand what it means to be a function and determine if a relation is a function. Number two, use a graph/equation to evaluate functions. And then number three, determine the properties of a function: domain, range, intercept, zeros, increasing, decreasing. Number one and number two, you have learned this before. Number three, some of these might be new, like the increasing and decreasing. Before we start, let me give you your joke of the day. Did you hear about the kidnapping at school? It's fine, he woke up. Kidnapping. All right, so we're going to start with relations. Number one, graph the following relation on the coordinate plane. A relation is just a set of points or a set of ordered pairs. And when we talk about ordered pair, we're talking about x, comma, y. The x is the first in the order, and then the y is the second. So we can draw or represent a relation as a set of points, and you'll notice with these brackets here, that means set or a group. Now, so we can write them out as x's and y's, but we can also write them visually in terms of graphing them on a plane. So -2, 5, -1, -3. And again, it's always x and then y. 0, -2 puts us on the y-axis. 3, 0, we go right 3, but we don't go up or down. So we're on the x-axis. And then 5, -3 puts us here. So we can represent a relation as a graph. We can also represent it as a table of points, where we'll make x this first column and y is the second column. So again, -2, 5, when x is -2, the y value is 5. -1, -3. It's important that I match up the correct x value to the correct y value. In this case, 0 for x gives us -2 for y. It doesn't give us a different number. 3, 0, and 5, -3. Now, there's another way we can do this. We can draw what is called a mapping. And with a mapping, we'll represent the x's and the y's as two ovals. And in this case, the x values, I'll write those down: -2, -1, 0, 3, and 5. Now the y values, if I put them in order here, from smallest to biggest, we would have -3. Now notice we have two of those. Two of those y values are the same. I'm only going to write it one time, and then the next number is -2, and then 0, and then 5. And what we do is we draw arrows from the x value to the corresponding y value. So -2 goes to the 5, and then -1 goes to -3, 0 goes to -2, 3 goes to 0, and then the 5 also goes to -3. Okay, so that's called a mapping. That's the one that we probably use the least often. Graphing and table, or just writing the set of points. Okay, so these are all ways that we can write or picture a relation. Now the domain, which we'll use a capital D for, that is the set of x values in our relation. So in this example, if I use the table, we can say D equals, and our x values are -2, -1, 0, 3, and 5. The range is the set of y values, and we'll use a capital R for range. Now again, you'll normally see this in a chronological order, so the smallest to the biggest: -3, -2, 0, and 5. Notice that the domain here has 5 values, but the range has 4. Remember that the -3 for the y value got repeated, so I don't need to write that 2 times. So domain is your x's, range is your y's. But we also have some other names that you'll see. Domain sometimes is referred to as the input, is what you put in, and the range is what you get out, is the output. And that leads us to the idea in the second section here of a function and what it means to be a function. So a function is a relation. It's a set of points where for each element or value, same thing as value, for each element or value in the domain, there exists exactly one corresponding element in the range. All right, so go ahead and copy that down. Let me read through that again. A function is a relation. It's a set of points where for each element or value in the domain, there exists exactly one corresponding element in the range. In other words, for each x, there is only one y value. And actually, I'll say there is exactly one y value. So for every x, there's exactly one y. The idea of a function is that if I take an x value, I put it into my function. Imagine this box is like a function machine. And what comes out of that is a y value. And to be a function, it means for every x, there can only be one y. So the thing to kind of remember, the easy way, is just to think, in a function, x cannot repeat. X can't repeat. If x does repeat, then it's not a function. Okay, and the idea is that if I put the same x into the function, I should get the same y value every time. If I put an x in, let's say I put in 2, and one time I get 3, but then the next time I put in 2 and I get 5, then that can't be a function because the x value is giving me different y values. All right, so in number 2 here, let's do a few examples. Are the following functions? State yes or no. If it's a function, state the domain and range. All right, well, to be a function, x cannot repeat. So if we just look at the x values, 5, 1, -3, and 0, those are different values. So we would say, yes, this is a function. The domain is your x values, so -3, 0, 1, and 5. The range is the y values. Now the y's, I'll underline those. -4, 0, 1, 6. Now in the second example, in part B, x is always the first in an ordered pair. So we have 3, -2, 0. But notice that we have the same x value here. The 3 is repeating. One time it gives us a y value of 3, but the next time it gives us a different y value. That can't be a function because for each value in the domain, there can only be one value in the range. We can't get two different values there. So we're going to say, no, that's not a function. Now we can still write the domain and range. The domain is the set of x's, so -2, 0, and 3. And then the range is the set of y values. So if I say y, the -1 repeats, so I only write it once, and then 3, and then 5. Okay, so again, the quick and easy way to determine if it's a function, look at the x values. To be a function, x cannot repeat. You can't get the same thing. So in part A, we have different x's, so we're okay. In part B, those two x values repeated, and they gave us different y values. That can't happen, so that's not a function. All right, let's flip it on the back. We can also try to look at this visually. Now, the idea of a function, remember, is we say that x can't repeat. Now, what that would look like visually is in part C here, so we've got this kind of shape, this curve here. We're going to use what's called the vertical line test, where we're going to take vertical lines and we're going to go through that graph. Notice that in this first line that I drew, I go through the curve in 3 different places. Now, if I were to actually label these ordered pairs, these points, this first one would be 2, 3 point something. Let's say 3.7. I'm just going to approximate. And then here, that's about 2, -1. Here, that's about 2, let's say -3.5. Well, notice we've got a problem here. Look at what's happening with your x values. When you have a vertical line, when you have points on that same line, they have the same x value. Well, if x repeats, that is not a function. So the vertical line test, if you can draw a vertical line that goes through the graph, the curve or whatever it is, in more than one place, that means x is repeating, therefore it is not a function. For part D, if I draw vertical lines, that goes through one place, one place, one place. Now the arrows mean it's going to keep going up and to the right. It's going to keep going up and to the left. But even there, if I'm drawing vertical lines, I will only go through that graph in one place. So we would say, yes, that is a function. Now the domain is all the x values where the function exists. Since it keeps going to the left and it keeps going to the right, we would say the domain is all real numbers. As an inequality, we could say the domain is from -infinity less than x less than +infinity. -infinity is all the way to the left. +infinity is all the way to the right. And a simpler way to write that is we're going to say parentheses, -infinity, +infinity. Okay, so this here is called inequality notation. And then this here is interval notation. Interval notation is what we're going to use for the most part. This is not a point. It's not an ordered pair. We're saying the interval, it's the space from -infinity to +infinity for that. Inequality notation, you might look at and say, all right, well, that's pretty easy to write as well. But if we want to write the full notation, we would say the set of x's slash -infinity less than x less than +infinity. That would be the full notation, which is a little bit longer than this. Now the range is the y values. And so for domain, we go left to right. For range, we're going to go from the lowest to the highest. The lowest y value is here. And that's at, the y value is -5. Okay, so the range, if I write this in interval notation, is -5, comma. Now the arrows keep going up. So that means we're going all the way to +infinity. Because the arrows mean it's never going to stop rising. Now with infinity, we always use an open parenthesis, a normal parenthesis, but for the -5, this is an actual point. This value is part of the range, so I'm going to use a bracket That's closed. That means that negative 5 is part of my solution. All right, and then the last graph here, part E, we have a horizontal line. So if I do the vertical line test, no matter how I draw it, I only go through in one place. So yes, that is a function. The domain is from left to right. Well, we go all the way to the left, all the way to the right. So that's all the real numbers from minus infinity to positive infinity. The range is the lowest to the highest, but notice that all the range values are going to be positive 3 if you plot all these points. So in this case, there's only one value for the range. I'm going to write that as a set. There's no interval because there's no starting and stopping place. It's just one number. And that is the end of part 1.